Yes, dear student, now in this video I will explain why do we need components of vector, why do we resolve a vector, means some applications of resolution of vector, application of resolution of vector. So generally a question is asked in exam in competitive as well as question asked in any for service or any entrance test. What is easier to push or pull a road roller? Road roller we might have seen on the roads, and in the farmers generally use rollers, but nowadays farmers do not use. So in figure 1 I have shown this cross section of the roller. It is center of the roller axle about which it will rotate on pushing. We are pushing by force F this way, making angle theta with horizontal. This line of action of force pass through center. We can resolve F into components along horizontal. Now if we draw perpendicular here, it will become base, it will become perpendicular. This is hypotenuse. Base upon hypotenuse cos theta. So this component comes out F cos theta, and this one come out F sin theta. Now F sin theta is directed vertical downward along the weight. So normal action of floor will N will be having magnitude F sin theta plus mg, and this component has increased the weight. You will learn later on force of friction is equal to mu n. So mu into n means when n increases, force of friction will increase. So it becomes rather difficult to push the roller. If in figure 1 we come here, again the same roller is there, same force I have applied to pull it, making it theta with horizontal. Now component of force. Now this is base here. So this component is F cos theta. This is perpendicular here. This component of sin theta. And sin theta is acting vertically upward, opposite to weight, and hence normal reaction now will be mg cos theta or mg minus f sin theta, because m plus f sin theta is equal to mg, so m is equal to mg minus f sin theta, and hence f force of friction mu is equal to coefficient of friction here, so it is mg into minus f sin theta. So now when we pull it making angle theta with the horizontal, then it becomes easier. So it is easier to pull a roller than to push. But very important thing here, whether you push or pull, if the force of pull on the roller is exactly parallel to horizontal ground passing through center, this way or this way, then it has no vertical component. So in this case it is equal here whether you push or pull. I think it must be very clear to you. Only that difficulty arises in pushing or pulling when we apply force making certain angle theta with horizontal. This was one example. We can understand, we can give explanation by resolving force into two components, otherwise become difficult. Keep on telling different things, but person will not understand. Now I give one more question here based on components of vector. An aeroplane takes off with velocity of magnitude 800 kilometer per hour, making an angle of 30 degree with horizontal direction. Find the horizontal and vertical component. So very simple. Aeroplane takes off. Actually you can say this is the horizontal ground, this is vertical direction, y axis you can take x axis as horizontal direction. Horizontal means the direction is parallel to our surface. So aeroplane takes off at 800 km per hour, making 30 angle degree. So now this is here sum of these two velocities. You can say here, if this is v, magnitude of velocity v, then it is v cos 30 and it is v sin 30 with 30. So horizontal component of velocity of aeroplane is equal to Vx is equal to v cos 30, v how much, 800, cos 30 root 3 by 2, so it comes 400 root 3 kilometer per hour. While vertical component Vy and 800 sin 30 1 by 2, so 400, yeah, write 800 into 1 by 2 means 400 kilometer per hour. So when aeroplane taking off, then it is rising up with velocity of 400 km per hour and going horizontally also, moving forward with velocity of 403 root 3 km per hour. So that way we can understand, you can understand why it is easier to use flyovers. By when you want to go to height, you use ladder or inclined plane like flyover. So if you try to go up height vertically straight, then it is difficult. But if you use inclined plane, it becomes easier. I am making one demonstration here. Suppose it is an inclined plane and you want to pull this weight and suppose the plane is, this inclined plane is smooth, means no force of friction. This angle theta, weight mg downward. Normal reaction of plane this way. Actually plane reaction you will learn in chapter 5. I have given my own videos and posts. So here again we your MG into two components. This is base, this is perpendicular. Perpendicular this way, base this way. So this component MG cos theta. And this one MG sin theta. MG cos theta is balanced by normal reaction. You need not to apply any force for this. So when you want to pull it up by applying force, the force applied required is mg sin theta. Smaller the theta, lesser the value of sin theta, and hence lesser the force. So our inclined plane or our ladder or our stair should have a small inclination, not large inclination, so that we can go up easily. If you make the slope high, then it will be difficult because this component will become more and more. So you will learn later on in every chapter dealing with vector. We need the resolution. I told here the how to resolve and what is the meaning and what is the use of resolving a vector into components. Thank you.